Afternoon, everyone. In case you are confused, this is not the overflow room, so you are stuck with me for the next 75 minutes. Just want to get that out of the way. So, my name is Bryson Tyrrell. For those who don't know me, when I submitted this, I was a desktop service desktop service specialist with the IT department at Jamf Software. Since then, I've actually transitioned to be a system administrator on the cloud and delivery team. So nowadays, I work on Jamf Cloud and the automation behind it. So I'm here to talk all about Docker Compose and how Docker Compose changed my life, which that sounds kind of strange here. So it might help a little bit to know what it is I do so that I can actually make a statement like that. And really, in the last year of my life inside IT, I wasn't really doing so much IT support as I was building custom solutions for the IT team. Those things were integrations, small web services, things like our internal HipChat plugin for Jamf Pro, a demo photo server for Apple School Manager for the sales team, and then a DNS registration service called QuickDNS that we use. As a system administrator, now on the cloud and delivery team, I'm actually, like I said, working on the automation behind Jamf Cloud and building onto those tools. But across all that, I was doing all these things in Python. So I was sort of a developer, but not really a developer. So question is, how does Docker Compose fit into that narrative? And really, there was a way I was doing things, and then after being introduced to Docker Compose, it ended up reducing the complexity of what I was doing by making my testing process a whole lot easier, making my testing process a lot more consistent, and then in turn, that somehow led into making my deployments a lot simpler by leveraging this one tool set. So I'm going to go into some background here as to all the things that actually tie into me using Docker Compose, and that's this stack of technologies that I use across all these projects at Jamf. Like I said, Python, if you know me, I'm actually all about Python. It's pretty much the only language I use for doing anything. My web applications are all written in Python, and they use a micro framework called Flask. And it's called a micro framework because it's the bare minimum of a framework you need in order to start building a web service. It doesn't contain a whole lot of stuff on top of it. You have to plug in the things that you want. That makes it really lightweight. It's really flexible, but it's still a powerful tool set. So that's at the core of every application that I'm writing. Backend, data storage, persistent storage. I have a database for that, of course. So for the most part, I use MySQL. Nothing locks me into using that. It's just that everyone around Jamf Software knows MySQL. It gets used in our own product. So I just sort of stick with that to make things easy. And then on the front end, I need a web server. I need a web server that actually interfaces between my Flask application and the real world. So requests come into the web server, and the web server proxies them to the application, and that executes the code. Flask does have a built-in server component so that you can just call it from the command line and start it. But that's just a development server. It's single-threaded. It's not meant to handle more than one request at a time. It's not meant for production. So there's actually another component in that mix, because Flask is part of a standard called WSGI, Web Server Gateway Interface, that's defined in Python's PEP 3333, if you really want to go read it. I never have, but that's where it is. So this is just a universal standard. A lot of things use this. Different Python frameworks use this. Other frameworks in other languages use this. It's just a protocol, a unified set of instructions that they all follow so that they can all be loaded by. You can switch in and out the server component that's actually executing the code. The one that I use the most is called UWSGI, which that's actually kind of confusing because the standard is called WSGI and then they named their project UWSGI. Another really popular one that you might have heard of is GUnicorn or Gunicorn, as I call it, and that one's more of a pure Python implementation. But that's part of the standard. These things can be intermixed to find the one that works best for you. This is the one I work with. So all these components need to talk to each other. So Nginx takes in requests over port 80 or port 443, it proxies those to the WSGI server, which is over port 5000 because that's the default port this happens to run at. And then it is executing all the code in my Python application. And then the Python application is making queries out to the database over port 3306. So let's talk a little bit about what my development process used to be, because I used to do things very, very poorly. And to start that off, I have my top-of-the-line hardware that Jamf gives me to do my work on, like this white MacBook here. Only the best. For actually building these larger projects, I use an IDE called PyCharm. And using an IDE gives you tons of benefits. The most common one that people like to talk about is syntax highlighting, code completion, so it's actually populating possible results for what it is you're going to be doing as you're writing your code. The other big thing it comes with is a debugger. So if I want to run my application, I can actually, as it hits errors, start walking through my code to see what it was doing so I can track them down better. Those are all really nice things that it does for me. Now, if I am firing up my application in debug mode, and my application is supposed to connect to a database, well, I don't install MySQL on my Mac. I don't want to have a database server running on my Mac, so I don't have that I don't necessarily have that available to me. I don't want to spin up necessarily a whole virtual machine just to run MySQL. So I thought, well, it's okay. I can just use the default option, which is to have it write to a SQLite file. And sure, that works. It just does I/O operations to the disk to this file as I'm testing out my application. But it has tons of drawbacks because it's a SQLite file, and I'm not testing against an actual running MySQL server to make sure that the things that I'm doing are kosher with that. For example, in Flask, using SQL Alchemy, you have to define the database models, the tables, and their columns, as code objects. But you can get away with not defining certain attributes on those if you're just using SQLite. And then if you try to connect this to a MySQL database later, it's going to throw a ton of errors in your face because you didn't define the length of a string, or you didn't tell what type of it. You specified an integer, and you're trying to write a float value. Things like weird fringe things like that. Well, not fringe things. It's just that they work for a simple setup, but they don't work in an actual production setup. So, and then the other thing is just that you can get away with a whole lot of things while you're testing, like sending files up to it and having them written to the database or written out to disk. But MySQL has some configuration that comes with that, like for things like max packet size. And if you have a large enough file that you're sending that exceeds that, it's going to throw up an error because you're trying to send too much data at once. So there's a configuration portion for that, which I'm not even covering at this point. Then the other half of that was the fact that when I'm firing this up, it's still using that development server I talked about. So I'm not actually testing this application like it's behind a real-world web server and it's proxying traffic. And that may not seem like a whole big deal, but there are a lot of other little things that you might need to account for. One other big one, I don't have a TLS certificate on my development environment, so I'm not accounting for services talking to my application over TLS. I don't have anything configured again for things like file transfers, because you're going to want to configure max content size on the web server to allow for the sizes of files that you're expecting to have come through. If they get big enough, you're going to start getting errors because the web server is rejecting it because the file's too big. So with all these differences between my local testing environment that I just sort of ad hoc do, and then the actual production environment, it caused a whole lot of frustration for me, because I'm actually building up technical debt in my own development process that I'm just going to have to go back into the code and fix, or back into the configuration files and fix, when I'm actually getting to the point where I'm ready to deploy this thing. And nope. This whole process really wasn't working for me. And I was just doing one-off projects, but they were taking longer because I wasn't accounting for so many variables in between my test environment and my production environment. There's just so much extra work that had to be done, when it came time for deployment. And deployment was worse also in many other ways, because on my Mac, I'm just running something. I have Python on there with all the requirements already installed. But it gets different when I'm actually setting up a virtual machine to act as the production server. So, I mean, this is sort of kind of what I have to go through on a brand new Ubuntu virtual machine, because we use Ubuntu 16 for most of what we run on our virtualization platform. So I need to go through, I need to run apt-get update, apt-get upgrade to install to make sure all the patches are on there. Then I need to load Git if it's not already on there. I need to install Python 2.7 because 2.7 doesn't come on Ubuntu 16 anymore. I need to install the components for uWSGI, the components to run the actual application code. And then I have to install the Nginx server. I have to clone my code repository into the right place, fix the permissions for that. I need to then copy my configuration files for both Nginx and uWSGI before I can actually start them up. And like I said before, this is the part where I'm getting this thing ready, and there's actually going to be a whole bunch of tiny little flaws in my development process that are now cropping up, and I have to go back and fix all those things and repeat some of these steps. Plus, later on down the line, when I have to go upgrade these servers, I'm still repeating a lot of these steps again as I'm upgrading them. And then there's just the whole fact that I'm a one-man show in the IT department when it comes to actually writing these applications. And the directive was, Bryson, we want you to do this stuff, but if you get hit by a bus, somebody needs to be able to spin up a new copy of this server application. We've all been there, right? If you get hit by a bus, is someone actually going to be able to recreate what you did? So I had to write lots and lots of very specific documentation, because package requirements would change between these applications. They weren't the same Python packages. Some of those Python packages required additional OS packages to be installed in order to work properly. And the configuration files would also be different between them. So I had to do one sheets, essentially, for every single server on how to do a new one from start to finish. And that is a lot of documentation to maintain. That's a lot of writing. It makes you feel really sad inside when you have to do all that work for something that you probably, no one else is probably going to have to do, but just in case. So that was life for a little while for me. And the thing was, I was only doing like 3 or 4 of these integrations, and I was the one personally responsible. There wasn't any justification or real need for me to start standing up things like Ansible or some other tool for creating server infrastructure for any of this. So I was doing manual server creation by hand for a while. But you know what? There is another way besides just having documentation and having scripts and having all these pages of one sheets for people to go through. That other way, for me, was Docker. So, what is Docker? And if we're talking about Docker, really for the whole thing, the whole Docker solution, there are 4 components to it. The first component is Docker itself. And Docker is the utility that you're going to be using for creating images and then running containers. And we're going to be covering a little bit of this as we go through this. Docker Compose sits on top of Docker. This is the orchestration tool that allows you, and it's the namesake of this session as it is. This is the orchestration tool that lets you define what images you want, what gets built, and then what runs. So, and how they're all linked together. And we're going to be covering that a whole lot in a little bit here. Docker Machine. So those first 2 tools don't really do much for you at all if you don't actually have something to deploy images to and run those containers on. So Docker Machine is a tool for provisioning Docker hosts and also configuring swarms. So Docker hosts can be pretty much anything, but usually they are either a bare metal server with a ton of resources, or they're or a cluster of servers, or they're virtual machines or a cluster of virtual machines. And you can use Docker Machine to provision the Docker engine onto those so that you can remotely build images and then spin up those containers. And then swarm is when you have a cluster of all those Docker hosts together and they act as one. So if you're deploying a containerized application and one of your containers, there's supposed to be like 5 copies of it running, say a load balanced application. Well, in a swarm, those will be evenly distributed across all the hosts that are available in that swarm. So it's scaling and performance optimization, and also redundancy in case you start losing hosts for some reason. But machine and swarm, we're not really covering those. We're just focusing on these top 2 up here. And we have to get into Docker first before I can really start describing how Docker Compose works. So, back to that question about what is Docker. From their website, Docker is the ability to package and run an application in a loosely isolated environment called a container. That's pretty dry. But, it does aptly describe what it does. And I don't want to go into super detail about Docker. There are a lot of resources out there. If you want to learn more about it, I'm going to touch on some of those a little bit later. Pepijn did a presentation back in 2015 about Docker, and he goes into a whole bunch of examples during that presentation using it, and you can find it right there. So there are a lot of really cool things that you can do with Docker, and at a high level, if you're looking at this diagram, sort of like what I was just talking about, if you compare a traditional virtualization platform and then Docker, you can see that there's a whole lot of overhead that you get rid of when it comes to Docker, because you are not actually virtualizing the entire operating system, just the pieces that run on top of the operating system, the actual stuff that makes up your running application or service. So you're able to actually deploy more on less. And there is the added bonus that they are all, to a degree, isolated from each other. So this is a Docker command. This is for me to spin up a MySQL server. So we're going to assume that I've gone ahead and created a Docker host using Docker Machine, and it's on my Mac. It's created inside VirtualBox, so I've got this lightweight virtual machine that's actually available to me as a Docker host now. Using this Docker command, I can spin up a MySQL server inside that Docker host and have it available to me at that IP address over port 3306. So doing this, I would be able to take my development web application and point it to an actual running MySQL server so that I can get that sort of real-world production behavior. Now, there's actually a lot on the screen here, so we are, in fact, going to step through it. So up here on the screen, this top line right here, that -D, that means to run the container detached. And what detached means is if you were to omit this flag and just run the command, you'll actually see all the log output from the container live in your terminal window. So it's actually running it like a process. And if you quit that, it'll actually terminate the container. You run -D, it'll return you back to the terminal prompt after it successfully fires up the container. So it'll be running, but you won't be tailing the live log output anymore. The name option is so that instead of Docker giving it a randomized name, which is, I believe, 2 random scientists joined together, you can instead give it your own name so that it's more easily identifiable, especially if you have a bunch of containers running on one host. So these next 2 lines, so with VirtualBox, when you have a virtual machine, VirtualBox will automatically mount your user directory into it as a shared mount point. So that way, if there's content in your user folder, you can access it in the virtual machine. So what I'm actually doing here is I want to persist the data in the MySQL database, so that if I take the container down and spin it up again, it will be able to it will still have all that same information in the database. This is important because containers aren't virtual machines. They aren't persistent. They're ephemeral, which means that when you create a Docker machine and you have something that's actually saving data to the disk inside that container, well, that container, as soon as it goes down, it wipes everything. No changes are ever saved. When you start it up again, it's from whatever the base image was. So if you want to save data, you need to actually mount a volume into it at whatever point in that directory structure that you want the data to be saved. The U flag is sort of a hacky workaround because there's this weird permissions error from the fact that I'm actually doing this loop from there's a directory in my user folder that's being shared through VirtualBox that I'm mounting into a container. So if I don't have this user flag to set the user and the group, which I pulled this off of an issue on Docker's GitHub, it runs into permission errors when it tries to write to that volume directory. So that is specifically a fix for that. You only run into it when you're trying to use mounted directories from your user folder. If you're doing volumes a different way, which you'll see in a little bit, you don't need that flag. You don't run into this problem. So here, when you fire up a container, even if it serves traffic over a certain port, there's this network layer that's specific to the Docker host environment, and it doesn't get exposed to clients that are outside the host. So even though the MySQL server might be running and it's available to take stuff over 3306, unless you map it to a port on the host, you aren't going to be able to get traffic in from the outside. So this is specifically telling it I want to map port 3306 on the host to port 3306 on the container. This is what's going to enable me to have an external application talk to the MySQL container on the host. Another fun thing about containers is that if you want to set it so that a running container restarts if it crashes on you, it can just do it automatically by just doing always. Restart always. If this thing goes down, immediately bring it back up again. Helps reduce downtime. Now, these are environment variables that are getting set inside the environment for when this thing spins up. And when you go look at official images, like the official MySQL image, there are a long set of environment variables that you can set to configure it for launch. So the MySQL root password is actually an optional one. If you don't care about the root password to the MySQL server itself, you can omit this and it'll randomly generate one at startup. So if you never actually have to do anything as the root user inside the container, which you rarely actually do, you don't have to set that. Then you give it the MySQL database, give it the name of the database that you want it to create when it fires up. And then for the user and password, give it the username and the password that you want to set permissions to that database for. So when this thing spins up, it's going to set a root user password, it's going to create a database, and it's going to grant all permissions on that database to this user I just specified. And then we have the image. This is the image that I want it to build. And because I'm just giving it a tag and then a colon and then the version number, by default, it's going to go out to Docker Hub. Docker Hub is kind of like GitHub, but it's for Docker images. And all the official ones are housed out there. And in terms of the MySQL one, I'm saying I want the MySQL container, and I specifically want the 5.7 major release. I could be a lot more specific because they do publish the minor version images as well, but I don't care about that because I want the sort of the minor version updates if I respin this container, or rebuild this image. So I'm leaving it at 5.7, so it's always 5.7, but it's whatever major, minor, and then the patch version. I'm sorry. So whatever the patch version is, I get the latest one of that. And you're hearing me interchange image and container a lot, and you might be a little bit confused right now. Think of, in terms of a Mac, think of the Docker image sort of as the golden master image for the ye old days of imaging when it was a thing. Anyway, so that's that's not like a manageable endpoint. That's just a state. Like when you deploy that thing onto something and it becomes a manageable endpoint, it might change afterwards, but it's not something that you actually affect right there. It's sort of like in those terms, it's kind of similar. The image is what was created. It's not running though. When you fire up a container, that is loading the image into a running service. So I kind of butchered that GM thing. It was actually better in my notes. I should have looked closer. Anyway, this is what it looks like in a terminal window. That's actually pretty small. We'll deal with it. This top part right here is just me pasting the command into terminal. And then when I hit enter, it actually will spit out this really long generated ID string. Every single object that Docker creates on a host for whatever it is you're running gets a unique ID just like this. And then there's this command, docker ps-a, and that tells it to list all the running containers on this server. And fun thing about all the Docker commands across Docker, Docker Compose, and Docker Machine is that their subcommands kind of loosely resemble Linux and Mac shell commands. So when you want to list out everything that's available, like Docker image ls, that's what you use to list out everything. So it sort of mimics that sort of terminal interaction. In the first column there, that ID is actually the truncated version of that super long ID from the last step. Then the image that we spun up this container from, we can see that I created this thing 5 seconds ago from when I took this screenshot. We can see that it's been running for 4 seconds. And then under ports, you can see the host address at 3306 is being bound to the containers port of 3306. So that's what's allowing traffic to come in. So after all that, now all I need to do is put in the IP address of the Docker host at port 3306 into my application, and now it's able to talk to a MySQL server as I'm running it in debug mode. And that's great. So, and plus, if anything ever goes wrong, I don't need to worry about cleaning up a bunch of files and reconfiguring MySQL on my Mac or in a virtual machine. I just destroy this container and spin up a clean one. And since I have the volume mounted, if I want to reuse the database data from my last run, it's still there. So that's pretty awesome, you know? That makes me kind of happy because that was super simple. There's a but though. That only covers MySQL. I need to do this with web servers as well. So that Nginx component, well, I need to be able to simulate Nginx. I need to be able to, test my application as it's running behind a live web server. And then, like I said before, different applications I've written have had different requirements. QuickDNS actually uses a bind server private to itself in order to write out DNS names because it's supposed to be part of a what do you call that? Well, it's supposed to be tagged for a subdomain on your main direct DNS server or DNS service, and so it uses bind9 for that. So that means I've got 4 components there. I've got MySQL, the web application, Nginx, and now I need to throw bind in there. Other applications, I might be expanding them to include Redis, so I can do queues or in-memory caching or anything like that. Well, that's another container that I would need. I need all these things bundled together. So we're dealing with not just one thing. It's talking about a multi-container environment in order to properly test out my application as a real-world deployment. That scenario brings us to Docker Compose. So, what is Docker Compose? Docker Compose is a tool for defining and running multi-container Docker applications. That's great, but how does it do that? You use a Docker Compose file to configure your application services, and then using a single command, you create and start all those services from your configuration. Again, both those quotes are straight from their website. But how does that look? How does it actually do that? So a Docker Compose file is a YAML document. What is YAML, you might ask? Well, YAML is effectively hipster JSON. Someone decided at one point to take a perfectly defined data format and then jazz it. It doesn't have any reason for existing other than someone thought it was a good idea, and then a whole bunch of people adopted it. But anyway, YAML is in fact a superset of JSON, so it is bidirectionally compatible with JSON files. The big difference is that it uses indentation instead of braces in order to define the structure. Half of you who know me might be thinking, but wait a minute, Bryson, that sounds like Python. How can you hate YAML but love Python? Well, that's because Python's not a data format, it's code. YAML is a data format, and it's one-to-one with Python objects, which, guess what? They all use curly braces if they're dictionaries. So you know what? YAML kind of ruins my life once in a while. So I'm done. This slide was not entirely about me bashing YAML, but it deserves to be bashed a little bit. The fact is, this is what Docker uses. So we are stuck with it. But the cool thing is, by default, it really just wants you to have a file called dockercompose.yaml inside the directory that you're going to launch from. If you have this file, you don't need to do anything when you run the docker compose command. So we're going to go over a lot of examples of this in the coming slides. And that command looks exactly like that. If you're inside the directory where you have your compose file, where you've defined all your services, and it's that default name, you just need to do this, and it starts everything on the host. So let's start going through what that looks like. Here is our Docker command from earlier, and then we translate that into a compose file. Even though I hate YAML, that looks a whole lot better than a shell script. So it's a bit cleaner, but this is also going to be so much easier to maintain, and you can tell that it looks really simple for me to start adding on additional services and components. So now all of a sudden there's this new feeling. There's this really great feeling inside as I'm taking in all these new tools and the way that they're going to make my life better. So if you're wondering where all these GIFs came from, if you haven't seen the JavCloud commercial, the fake commercial that we released some time ago, I got used for that because the guy who was going to do it opted out at the last second, and then they grabbed me and threw me in the server room. So I'm having a little bit of fun with myself. All right, let's start going through this thing. Every YAML file needs to have the version defined. And I need to explain this a little bit because it can seem kind of confusing. Because there are versions of YAML file of the compose file syntax, and then there are versions of the Docker compose binary, but they don't necessarily map one-to-one. So for example, this is a version 2 syntax file, so it doesn't support a whole bunch of really cool new features that are available in version 3. This will work with new versions of the binaries, though. So if I have really new versions of the Docker Compose toolset, it will still work perfectly fine with my version 2 files. I just can't use all the new goodies. Conversely, though, if I get my hands on a version 3 or 3.1 Docker Compose file, and I try to use it using an older version of the binary, it's not going to support them. Thankfully, Docker does have a great web page where they list out the minimum versions that these compose file formats conform to. So it's not that hard to figure out what version you need to be at a minimum in order to do this. But everything is backwards compatible all the way. So if you have the latest version, you don't need to worry about this. Of the binary, you don't need to worry about the file version too much. So moving on here. So services. This comprises that whole shell command that we saw earlier. But it's nested in. So when we want to have multiple containers, they're each going to be a key value underneath this services tag. And right now we only have our MySQL container. So we go in one level. This is MySQL. We go in again, and then these are all of those flags that we were setting for MySQL. You can see that we've got the user thing up there again. It's easy to tell that we are explicitly saying we want the MySQL 5.7 image. There's that very long volume mount string again, the restart command, the port map. Everything looks pretty much the same. Now, here's our environment variables again. And we're still doing these things plain text, but in a little bit I'm going to show you an alternative to all this. All right, demo time. But I'm going to try and emulate Rich Trouton a little bit for this demo. So I'm going to use all three of those tools I brought up before in concert for this. Docker Machine, Docker, and then Docker Compose. So I've already got a Docker host called Sandbox on my Mac. It's created through VirtualBox again. So I'm going to connect to it using this eval. So eval, and then you have it capture the output of Docker Machine and the name of your virtual machine. That will set all the environment variables so that when you use the Docker command, it knows what host it's supposed to be talking to. So, moving on. In my current directory, I have the compose file that we were just talking about, and I also have that local directory that's being mounted for the MySQL data that's in my user folder. So I'm now going to be launching the MySQL container by running Docker Compose up. And you can see I'm actually using a -d flag here again. Same thing as with the Docker command. If I don't use -d, that means I get to watch all the terminal output of all my defined containers and tail them. And then if I cancel it, it'll just kill all the containers. Use -d, and it runs in detached mode so that I can actually do other things in the terminal. Like here, right after I ran that, I ran docker PSA again, and then I can see it fired up my container and it's ready and available. Then if I want to take all this stuff down, you can kind of guess it, it's Docker Compose down, and then that will remove the containers and delete the containers, but not the images, just because when you take down a container, you can stop it without removing it, so then when you start it again, it'll just go from that cached container that was already built. If you do a down command, it removes the container, it will rebuild the image and then launch the container. So now that the container is running, I can continue to use the Docker command to inspect the individual running containers. So like right there, I did Docker logs and the name that I gave that container, and then I got to see all the log output from it. And there's a whole lot of helpful commands in there, either on their website, or if you happen to have the Docker utility installed, you can just type its name, hit enter, and you can see the list of all the things that you can do to interact with containers, including shelling into them, which I'm not going to demonstrate as a part of this presentation, but if we've got time later, I probably can. All right, so now that we've got Docker Compose, and I know I can define numerous services, it's actually time to go multi-container. So I've got all these components, and I'm going to convert this now into a full Dockerized application so that when I want to test my code, I'm testing it into a production-like environment. So I got lost in my notes for a moment here. All right, first step is that we have the Docker host. This big blue box here is going to represent our Docker host. Now, for the services that we have up here, we're going to be defining containers for them. So here we have the 3 containers that are going to make up our application. MySQL is in its own container because, like we just saw, I had a MySQL service defined. Nginx is going to have its own container. Then the web application is going to have its own container. And these 2 components are together because the code is just files. So really, we're dumping the code onto a container that we're going to define, or an image that we're going to define. And then we're going to also have that image install the uWSGI server as a part of that and copy the configuration files. We're going to go over all that real soon here. Now, Docker has, remember when I mentioned just a little bit ago how there's that concept of the internal Docker host network so that you can't actually hit containers directly unless you expose them on ports? Well, you can actually, that's just the default network. You can further segregate out how your containers can talk to each other by defining networks and then attaching containers to those networks. So we're going to create 2 networks, one that's going to be called proxy, the other that's going to be called DB. We're going to attach the DB network to the MySQL container and the web app container, so only they can talk to each other. And we're going to attach the proxy network to the Nginx container and the application container. So nothing about the Nginx container can ever touch the database container. So it's a small layer of network security inside your host. And the only thing that will be exposed on here is port 80 and 443 for HTTP into Nginx. And that's the only exposed port on the host. Nothing else will be allowed in. And because it's only to the Nginx container, and the Nginx container can only proxy to the web application container over 5,000, there's no way for external traffic to get to the other running services. Then we're going to be doing a volume for the MySQL container so that it will persist our database data. But this is going to be all running contained within the host. I'm going to show you now how to set up a volume in Docker Compose so that it's actually storing that data on the host itself in a directory that's mounted into the MySQL container. Now, actually, not this one. A little bit later I talk about that. This actually creates a data volume independent of all this that is only mounted into MySQL, and the data is saved there. So when you tear down all these containers, the volume is still left behind and its data is still safe. All right, I've switched into version 3 here, but I'm actually not using any version 3 specific syntax, so There's no reason for that. This is actually a copy and paste thing. All right, so we're going to update the original compose file. If you see the dots, that just means there's code below that or code above that we aren't showing, but it was there before. Here's those two networks I just talked about. You want to create a network in its default state. That's it. You just create these two items as a list or as individual keys under this networks keys. So we have services now and we have networks now, and we've created the proxy and database network. That was easy. Volumes. There we go. I now have a volume for my MySQL container. That's it. I have a volume. It's called MySQL. I have a service called MySQL. You can get away with this. It makes sense for me, but if you find it confusing, you don't have to do this. You can name your containers, images, and volumes and networks whatever you want. So we're going to make a slight change to the MySQL service where we're going to switch that so that's MySQL : and then the path inside the container that we want mapped into that volume. So you can see the syntax is just slightly different here, in which there's no pathing on the left-hand side. Docker Compose knows that we're referencing our volume down below, and it just magically works. All right. So as I mentioned before, Docker Compose builds images. Actually, I think I might have skipped that part, but like when you run Docker Compose up, it will build all the images first if there are special instructions or anything like that, and then launches the containers. Docker does the same thing. When you're doing Docker and you pass all those flags to it, it's building the image first and then launching the container. And Docker Compose just abstracts a lot of that stuff, so it's doing the same processes. So when we want to create a customized image, or just tweak an existing image, we're going to need something called Docker files. And Docker files are just sets of instructions for how to configure an image when you build it. And I'm not going to go super deep into them, but we are going to step through these ones so that you can see what I'm doing. So for this to work, we're going to tell the Nginx service the relative path to the directory that has all the components that it needs for building. In this last slide right here, we have an Nginx folder with a Docker file and its configuration, and then we have a web folder with a Docker file and its configuration. So again, we're doing some port mapping here. We're mapping port 80 to port 80, port 443 to port 443, and then we're attaching it to the proxy network. And we're also saying that it depends on the web application, which means Docker Compose will not start up the container for Nginx until the container for the web application has started. Oh, I had magic boxes. So those two files that are inside that local directory, this is what they look like. We have the Docker file on the left where from Nginx 113. So again, I'm actually defining the official image that I want to pull first before it does anything else. So this is the image for Nginx that we're going to use. Then I'm going to use the run statement to actually trigger a shell command inside the image. So it's actually going to run bin.rm to get rid of the default configuration inside that inside that image we just pulled, and then it's going to add that web app configuration file into. There we go. Then it's going to add that web app configuration file on the right-hand side here into the correct place inside the Nginx container, so that when it starts up, it's using this. And this is just the most basic of configuration files for Nginx with a Flask application. The upstream is where it's going to redirect traffic to. So when it comes in over port 80, in this case, because this one's not configured for TLS, when it comes in over port 80, it's going to redirect from anything from the root afterwards into that upstream, which is going over to web at 5000. You notice how there are no IP addresses in here? Another part of the Docker magic. The names that you assign to the services become their network host names inside the Docker host network. So when you want to actually tell something to talk to another service, you can get away with but just typing in the name of the running container and then whatever else you want. So like if something were to make a HTTP request within your running application to something else called like cache or store or whatever you name that service, it would just be http://store and then whatever the path was after that. And it will be able to translate that. So, cool shortcuts inside Docker Compose. All right, same thing for the web application. We got that build directory, but we're also tagging it to 2 networks because it needs to be a part of the proxy network and it needs to be a part of the database network. Proxy network so it can actually do the back and forth communication over port 5000 with Nginx. Database network so I can do requests to MySQL over port 3306. And this one depends on the MySQL container. So the web application container will not be started until the database container has been started. So we have now built a dependency chain into our containerized application where it will do database first. Database is up. Okay, going to do the web application. Web application is up. Okay, finally we'll bring up the web server. So one component does not start before its other required dependencies are already there. This is a lot bigger. There's a lot more going on in here. For my web application, I'm actually using the base Ubuntu thing, Ubuntu image thing. So, I work with Ubuntu a lot, so I'm just going to use their base image in order to build off of because I know what dependencies I need to install for my Python libraries in Ubuntu the best. So, Ubuntu 16.04, and then here's a much bigger run command, and I actually chained a whole bunch of stuff in here. So, this run command is doing a lot of what you saw in my documentation, where I had to specify all the things you had to install onto a virtual machine in order to get this going. Except now, this is actually a part of the process, so I don't need to document manual steps for someone to do. They can just, do Docker Compose up, and when it builds this, it will actually do all these steps automatically. The reason I'm chaining them together is because when you are building Docker images, every step that you put into a Docker file becomes a layer, and layers are fixed. So even if you do something in one step and then start removing files in another step, those files were present in the earlier one and they're part of that fixed layer and you can't get rid of them. So you're actually subtly bloating the size of your image unnecessarily. But if you chain a whole bunch of stuff together, you can actually limit the size of your layer. So because I'm doing a whole bunch of operating system stuff in this one big run command, at the very bottom there, I'm actually removing all that stuff that gets cached from all those apt-get commands. And then when that's done, that layer inside the image is that much smaller. So when if you get concerned about image size, which if we're talking about small things, this is not necessary because we're not running things at scale. But when you're running things at scale and you need to do a lot of images, this is the practice that they recommend in order to limit the size of your layers. I'm copying my INI file for uWSGI into the correct place on the server. So I'm etc uWSGI apps enabled. It looks for configurations here for when it starts up. So I'm adding my INI file in there. I don't have it on the screen because this was such a big one, but I have lots of examples out there that you can go and reference if you want to take a look at what uWSGI INI files look like. Then I do another run command, and this run command is actually all about pulling in the source code for my application over Git, then installing those requirements for Python, and then setting the permissions correctly. Again, I'm chaining those all together, so it's just one layer on the Docker image. And then there's this thing. So you didn't see this with MySQL, and you didn't see it with Nginx, but for the most part, every image has a command entry or a command entry or a Docker entry point, and that is a command that runs when the container is spun up. In the case of MySQL, it's running the binary to start the MySQL server, and that's its command entry point. For Nginx, it's starting the Nginx service. For me, it's going to be calling the uWSGI binary and pointing it to my INI file so it will start up the web application. So when this container launches, that is the command it runs in order to keep going. If you were to do a one-off command as a part of this, like it did something that was a one-time action, and it didn't actually go into a loop or start a service or something, your container would exit immediately because you spun up a container to run a command and the command finished, so the container came down. When you're dealing with services, you want to start the service so it continues running. So, I touched on this earlier. We still have plain text values in here. There are alternatives to that. If you omit them and just list your environment variables like this, instead of Docker Compose setting those environment variables from the text you entered, Docker Compose will read the environment variables from whatever environment you're currently in and then pipe them into Docker Compose. So when you're in your terminal, you can set these environment variables and then run Docker Compose up, and it'll just pull them in and put them into the host for when the container starts up. The other option is you can actually just define a file that has the name of the environment variable equals and whatever the value is. And then you say env file instead of environment and listing out all the individual variables, and it will parse that file and then set all the environment variables. So you can actually have a file set to do all this stuff. And the cool thing about doing that is for things that need to share environment variables, like MySQL and web app container, because MySQL needs them in order to create the database for you and make sure that you have permissions to it. And your web app needs the database name and the username and password in order to talk to it. So instead of defining them multiple times in your file, you can just have them all set in one environment file and have it shared across services. Another demo. All right, so I'm still connected to that same sandbox Docker host that we were before. So I'm going to tell Docker Compose to build all the images first. So instead of doing Docker Compose up, I'm going to do Docker Compose build, which this will actually do that first step where it creates all the images, but it won't start any of them. So this is handy if you're dealing with a bunch of running containers and you made changes, but only to one of the services, and you're like, well, I just need to rebuild this one image and then relaunch it. You can do Docker Compose build the name of the service. It will just rebuild that one service from the changes that you made. And then you can do Docker Compose up and the name of the service and just relaunch that one service. That's a really cool shortcut here. So that was actually wickedly sped up. It's not that fast. It takes a while. But I just had it go through and do all the builds. So now I'm going to run build again just to show you. And this is not sped up at all. I'm going to run it again, and you're going to see that it's, if you look closely, because this is small, I'm sorry, but you can see all over the place it's saying using cache. Because Docker Compose just detects changes. And then if there is a change, it will then, from that point, ignore all the cached layers and start redoing those layers. There's a gotcha. It has no concept of a change for the URL to a Git repo. So you have to do creative things, which I'm not going to cover the creative things as a part of this, or you use a no cache flag and have it from start to finish rebuild that service. We can talk about creative ways later on outside the context of this. All right, so now we're going to run Docker Compose up, and we're going to see in here the creation of the networks, the creation of the volume. All the images that we weren't customizing, it's now going to pull because it will not build an image where there are no modifications. It's just going to pull the image at runtime if it's not already cached. And now it's all done. And if we go on here next, I'm going to use that Docker command to list out all the running containers. And now you can see that we've got an Nginx container, we got the web container, we got the MySQL container. You can see it was really fast because these are small services, but 5 seconds ago, 6 seconds ago, 6 seconds ago, and then for the status, it's been up for 5, up for 5, up for 6. So that dependency chain held. And then if I list out the volumes, you can see that we got my volume right there. And under networks, when I listed those, you can see there are actually some extra ones in there. Those are the default networks that you don't touch those. Those are just the default types of networks. There's 3 of them. Then all the networks that you would build or define, you can actually specify details about them if you don't want them to be in the default state. Again, network drivers way outside the context of this session. So I just went over all the stuff that went into making my life so infinitely better when it came to testing my applications, because when I wanted to test it in a production-like environment, I just was committing code to my internal repo, and then I was rebuilding my container with Docker Compose, and I was launching it onto a host where it had a web server, and it had the application server, and it had the database, and everything was exactly like production. So, what about making deployment simpler? It kind of occurred to me as I was doing all this work that I kind of stumbled across a new way of deploying my applications, which was going to make it super easy to have other people do if I got hit by that bus. So here's that Docker Compose file spread out across 3 columns here. You know, it defines everything. Everything's there. There's the web server, there's the database, there's the web server, there's the application server, there's the networks that segregate them, there's the volume to persist the data in the database. So, like, why not just use this? I can secure those environment files so that only the right people have access to them. So if they have to redeploy it, they can just go grab the production environment files in order to redeploy the server. And when it comes to being able to test and go to production, I can just create garbage files that have, you know, Bryson 123 is the password for everything. And that just suffices for testing. And then there's, you know, the production set of files that actually have the randomized complex passwords and such that are securely stored somewhere. Nginx, however, well, what I just showed you where I'm only firing it up over port 80, that doesn't work for production. Never, ever, ever deploy something without TLS cert. Don't do it. This is 2017. The NSA is watching everything. But there's not that much that needs to change in order to make this fire it up with a TLS cert. And really, once I do those changes, there's no reason why I can't just use that as part of my testing environment. So here's an updated configuration file for Nginx, which is sort of the bare minimum to get TLS working. Or they still call it SSL because that's the key. But you can see the changes here is that instead of listen 80, I now have listen 443, and I'm specifying SSL. And then I have 2 new keys, SSL cert and SSL key. And I'm pointing them to a directory where I'm saying you're going to find the certificate in etc SSL certs, the name of my application, and name of my application.pem. Same thing for the key. Same location, but just name of the application.key. Those are the only things that changed there. Now, there are a lot of ways for you to get your certificate into a containerized application environment. The one you shouldn't do is have it copied in as a part of the Docker file. You don't do that because, like I said before, those files become a part of the image, and they're in the layer. And if somebody fires up a container, they can shell into the container while it's running and copy your private key. So don't do that. Instead, what I do is I will actually copy the private key and the certificate file onto the host itself. And then, another fun option with volumes, when you use syntax exactly like this, before when you saw this, it was that weird loop where the directory was actually in my user folder because I was taking advantage of the fact that VirtualBox mounts user directories. But in a standard Docker host, if I'm pointing out to a directory like this, I'm saying this directory on the host maps to this directory in the container. So I put these files, and they don't actually have to be in the exact same place. I could put them anywhere. But I could put these files into the search directory on the host with the correct permissions, and then just map that to the same location in the running container so that when the container fires up, it has access to those files, and then it's able to serve traffic over 443 securely. So when I'm testing, I could either use a wildcard search setup, for a test domain that we have, or I could just, it doesn't matter. I could just use a self-signed certificate and have it available on my host so that when it fires up, it's untrusted, but it's still being served over TLS, so I can still test it that way. So in the end, I actually did end up deploying those internal applications I told you about on Docker hosts. And my instructions, instead of those giant one-sheet documents that I talked about, they essentially distill down to create and connect to a new Docker host, clone the app repository locally, copy the, and for the application repository, actually I'm miswording, I create separate repositories for my Docker configurations apart from the application itself. So I have an app directory, or an app repository, and a Docker repository for that application. So they clone that, then they copy the environment files and the configuration files that they need from wherever we store the production ones, and then they put the certificate files on the host. Then they run the build command, and then they run up. And there you go. As long as all the files were put into place, all the paths are the same inside the Docker compose file, so everything just comes right back up. And things got a lot easier after that. So, if you want to know more, these are some starting points I recommend. There is Pepine's presentation from 2015 where he's actually just using Docker, and you can see a whole lot of examples of him running services with just the Docker command. Getting started with Docker Compose, these three are just Docker's official documentation. Getting started with Docker Compose is a great way to figure out how to use that. The compose file reference I use all the time, especially when I want to figure out creative ways of getting my images built to account for things like I'm rapidly making code changes. I needed to rebuild just the bottom part of that file, not the whole thing, because I don't want to watch apt-get logs, every single time I do it. And then lastly, if you want to go all in and learn a whole lot about Docker, there is a 6-part getting started guide that they have on their website right there. So, not too bad. We got 14 minutes left. There's the feedback link, and let's just do Q&A. And there was silence. Oh, wait, no. Secure yourselves. Haha.
Hey. So in the Docker file that lists out the command, there were strings separated by a comma. Is there a particular reason that that's the format that it's in?
For like when I was defining a volume?
No, when you were putting in the command that runs, like the thing that would run the bin or whatever.
We're going to have to go back a few slides here. And which part are we talking about?
It was the part where it defined CMD, and that's the thing that pipes into the Docker container.
Oh, so there's actually a use for the touch bar here. I'm going through my...
That.
So here?
So it looks like there's strings and they're comma separated, but nothing
So
else.
there are 2 formats that you can do for this command entry point. One is you can just do one really long string.
Okay.
The other way that it accepts, which is kind of like how the Python subprocess module works, is where you give it an array, and then you have the individual pieces for that command as chunks of that array. Okay. So if you're doing variable substitution into the command entry point from a build argument further up, that's the crazy stuff that I said we weren't going to get into, then you probably would want to do something like this.
Okay. Cool.
And I think this is the recommended way of doing it anyway.
Okay.
Back there. Here we go. All right.
Whenever you're referencing one of the images, you had like Ubuntu and then colon the version. Are you not using the latest tag for any specific reason, or is that not supported on all the images?
The latest tag is optional. So if you want to always pull in the absolute latest of something, you can either just leave off the tag completely, or you can do :latest to explicitly get the latest. If you're developing an application, though, you probably want to stick with fixed versions for what you worked with that you know works. Because part of the whole thing with containerized applications is that they're all fixed states. So however they were spun up in one environment, they will be spun up identically in another environment to their instructions. If you want to switch up to a newer version of something, you'd want to go back into your Docker file or Docker Compose file and then up those version numbers and put, preferably test that those new versions don't cause any problems with your running application. It's all about version control.
Okay.
Oh, come on, guys. We got 10 minutes. Do you really want to leave early? Everybody wants to get to the creamery just that much faster than the other guys, huh? All right, well, thanks for coming.